You know what? If we spend 30 minutes solving this, 40 minutes, something is wrong. Let's quickly go through this. Okay, we start with number 1C, the variable separable method. Variable separation. You tell me at your age you're not going to do it? Come on, you know better. Just make sure you're going to be good at integration. So we'll see some integrals that you should just polish up to make sure you're good. Let's put this. Number 1C, so I'm going to say, number 1C, thank you for giving me the walk in the park question. dy dx is equal to 2y minus 1 multiplying e to the negative x. Separate those two, my friend. Just separate the variables. Here, dy is on the left, so you're taking everything with y onto the left. Now, this thing is multiplying. When it goes there, it will divide. So you have 1 over 2y minus 1. dy with respect to y is going to be dx now goes to the other side. It will multiply. So it will be equal to e to the negative x dx. Then we introduce integral sign to both sides. 1 over 2y minus 1 with respect to y is equal to the integral of e to the negative x with respect to x. Now you have to be good at a little bit of integration, and this is going to be very important for us. So here is the idea. When you have something 1 over something, right? When you're going to have 1 over something, what you should just do is, if this is not a y on its own, okay, then what you're going to do is you are going to generate this top to create a value which is going to be exactly the derivative of the bottom. When you're integrating this fraction, try to make sure the top is exactly the derivative of the bottom. Then you get your answer as ln of the bottom when you integrate. Okay, so in other words, if I differentiate this, what do I get? I'm going to get 2, right? So that means because if I differentiate 2y, I get 2. If I differentiate negative 1, it becomes nothing. So the derivative of the bottom is 2. So I need a 2 at the top. So what am I going to do? I'll multiply this 1 by 2 to put it at the top, right? Then when you have done that, you then go outside of your integral sign and reverse what you have done to make the top be the derivative of the bottom. You just then go outside and reverse it. So what have I done? I've multiplied by 2. I'll go in reverse. I will be dividing by 2 outside. So here I'm going to say half here is going to be half integral of 1 times 2 over 2y minus 1 with respect to y is equal to the integral of e to the negative x with respect to x. Now I'm going to have half outside. It's reversing what is happening inside. Inside we have multiplied by 2. So it's 2 over 2y minus 1 with respect to y is equal to the integral of e to the negative x with respect to x. Now let's do the integrals. It's going to be now half the integral like this. When the top is exactly the derivative of the bottom, you just get the integral as ln of the bottom, ln of 2y minus 1. This is equal to the integral of e to the negative x. When you're integrating e, you bring it as it is first. Then if it's integration, you then divide by the derivative of the power. If it was differentiating, you bring it back. Then you multiply by the derivative of the power. Now because it's integration, you bring it back as it is. Then you divide by the derivative of the power. The derivative of negative x is minus 1. So we then divide by minus 1. Then we can add our constant on the right. We don't care where you add it. You could have added it on the left. So here you're going to have half ln of 2y minus 1 is equal to negative e to the negative x plus c. We can have it like this.